Case number 6. Look for the identity for the ratio of sine y and cosecant y. We can look for the identity equivalent to this when we try to express one of them in terms of the other. We're talking about the cosecant y. We can express it in terms of sine y. And the reason for that is we might see possibility of cancellation later or a better simplified form. Now, please remember that 4 out of the 6 trigonometric identities can be expressed as sine or cosine or a combination of both. Now, let's start with our numerator. This is still equal to the numerator of sine y because sine y is already a simplified form of trigonometric identity. But the cosecant y can be expressed as sine y. Cosecant y is the reciprocal of sine y. This means that cosecant y can be represented as 1 over sine y. This is the equivalent form of cosecant y in terms of sine y. Now, from this, we can now apply necessary processes involving rational expressions since we are dividing sine y here by a fraction at the bottom. We can use here the keep change flip method, the method of dividing fractions, and at the same time applicable to rational expressions just like this. Keep change flip method tells us to keep the numerator, so it will still be sine y here, sine y. Instead of division, we change the operation to multiplication and we reciprocate, we flip our denominator. Instead of 1 over sine y under division, since we change the operation into multiplication, this would be reciprocated. This means this will become sine y over 1. After applying the keep change flip method, we now have multiplication of terms. But please do not forget that this is also all over 1. And when we multiply expressions like this, which are rational expressions, you multiply numerator to numerator and denominator to denominator. The product of our numerator is sine y, and then there is an exponent here of 2. This is because there are 2 sine y multiplied with each other. All over 1 times 1, 1. But our numerator here can still be expressed in simpler form. Whenever you have a square of a trigonometric identity, you can do this. Instead of the square of sine y, you can write it like this. You place here the exponent, and you have here your angle. So this is sine squared of y. Since this is still all over 1 and the denominator is 1, so we can write it as it is. Now, the identity that we have found equivalent to the ratio of sine y and cosecant y is the square of sine y or sine squared y. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.